back to the class, we'll talk about indefinite integral. We've talked about definite integral. Now we want to talk about indefinite integral. Now, indefinite integral is just as simple as definite integrals. The first thing you realize is that when you differentiate a particular value or a function or an expression, after differentiating, if you reverse it back to the function, what you get or what you are doing is integration. For example, you have y is x squared plus 4. dy over dx of this will surely be 2x plus 0, which is equals to 2x. If you have a value, that's that. But if you have this value, so therefore what it means is that dy over dx is equal to 2x. But how do I get y back from this expression? That is indefinite integral. Good. Now, or you can call it basic differential equations, ODE. Now, from here I can have my value by saying dy dx is 2x. How can I reverse? How can I obtain this back? The process of obtaining this back will become y is equals to 2x. What is the power here? The power here is 1. Although it's invincible, but it's 1. So that will be 1 plus 1 over 1 plus 1 plus c. Y now becomes 2x squared over 2 plus c. 2 here, 2 here. So therefore, y is, when you cancel the 2 over left is x squared, so you have x squared plus c. So you've obtained this value back, x squared. But there's a question now. This c that is here is not the same thing as 4. That becomes the problem. Yeah, 17th century Leibniz had the same problem. Probably he will discuss it with Newton. But they created these theorems of calculus. Now, these two values are not the same. So because they are not the same, what do? Because this value can have things like x, you can have x squared plus 3, we still give you the same value. X squared plus 6 will give you the same value. X squared minus 100 will still give you the same value. So because these will still give you the same value, we don't know the exact constant that was here. From here, I didn't see the constant. Let's assume I was shadowed up here. I didn't see the constant. So when I reverse it back to the value of y, I don't know the constant that was there. So that's why I use the arbitrary constant, which is plus c. So that's where the arbitrary constant, because the c now stands for any constant that could be there. Whether it's minus 10, 200, 2 million, 17 minus 25, 7 over 3, whatever that was there, it has to be represented with an arbitrary constant called c. Now, it shows that if, for example, I have an example like I'm asked to find the equation. That's how you get questions. Find the equation of dy over dx equal to 4x plus 7. If you have something like this, it's a differential equation. Now from here, I can take my solution as my solution becomes y is equal to, this is the value. The differential value now becomes 4x. There's a value here, 1. That becomes 1 plus 1 divided by 1 plus 1 plus 7. Don't forget, the value is 7. There is a value of x in the back of 7. But it's just that it's invincible. The value of that is x raised to power 0. Anything raised to power 0 is still equal to 1. So that x raised to power 0 will come to play. You have x raised to power 0 plus 1 divided by 0 plus 1. So automatically that becomes 4x raised to power 2 divided by 2 plus 0 You have 7x divided by 1. So the final value of y now becomes, if 2 go here, you have 1. If 2 go here, you have 2. So that becomes 2x squared plus 7x. So that's the equation. But funny enough, you have your plus the value of c. The reason why the c is there, we don't know which of the constants that was there. So any constant that was there can be represented with the value of c. Now that is that. You can have other statements like, if for example you are giving values like, maybe you're told that the differential equation of a variable, say the dy over dx of a value is maybe is 6x squared plus 4x. You have something like this. You're told that you have something like this. I should find the equation. What do? Y now is equals to, let's get that equation. This is dy dx. Let's find it. So you have 6x2 plus 1, 2 plus 1. You have plus 4x, 1 plus 1, then 1 plus 1, plus the value of c. So from there you have 6x3, you have 3 plus 4x squared, 2 plus c. Rubbish cancel this. So you have 3x cubed, that's not the value of y, plus 2 here, 2 here. That becomes 2x squared plus the value of c. So that is the equation that brought about this. So when you differentiate this, you get it. But the only problem is that we don't know the value of the constant c. But that's not an issue. So after some time, we decide to ask ourselves, what about if we need to know the value of the constant c? That we have to come. We have to know the value of c. But before we do that, I want to take you into some indefinite integrals that tends to be a function of another function. Let's consider that is function of another function. It's very simple. Sometimes you see the questions, you ask yourself, do I expand? You can function them just the way you have them in the direct differentiation. They are very simple. Now, let's consider this. Let's consider something of this nature. Now, let's take another question as far as indefinite integral is concerned. But this time, we'll consider questions that have to do with indefinite integral, but they are functions of a function. Now, let's consider this, for example. Now, you have, you're asked to integrate 3x plus 1 dx raised to power 3. So you have integral of 3x plus 1 raised to power 3. Beautiful. Now, you ask yourself, am I going to expand first of all? No, you do not need to expand. You don't need that. What you need to do is to take out the function. Let's consider this, for example. Because if, for example, it becomes a root value, you cannot expand that. So let's consider this as a function. The first thing you do is let u be equal to 3x plus 1. Now you have u equals 3x plus 1. Now the first thing you do is du over dx, as if you are doing your normal differentiation. Now du over dx will give me 3, because the y dx of 3x is 3. The y dx of 1 is 0. So if you cross multiply this, you have du to be equals to 3 dx. Now, from du equals to 3 dx, you divide both sides. You divide both sides by the value of 3. If you divide there by 3, you divide there by 3, 3 will cancel 3. So therefore, this dx itself becomes du over 3. Now, the first thing I did was that I allowed the value inside this bracket, u to be equals to 3x plus 1. The second thing is that I differentiated both sides. Why is it du dx? The reason is because u with respect to x. Now I got 3. Now du divided by 3 is equals to, so if you cross multiply from this expression, you get dx. Now dx is equal to du over 3. So always remember now that we now have a value dx, and that dx has its own value in the other side of the equation as du over 3. Beautiful. That's good. Now, from here, I'll consider the next fact that this particular statement now becomes integral of u raised to power 3 dx. The reason is because I've replaced 3x plus 1 with u. So 3x plus 1 is now u. So that makes it u raised to power 3 dx. But don't forget, this dx itself now has a value. The value of dx now is now u raised to power 3 times dx now is now du over 3. So if you take the value out, what you are having now is 1 over 3 at the back, integral of u raised to power 3 du. So differentiate u raised to power 3 as if you are integrate u raised to power 3 as if you are doing your normal integration. Let's integrate that. That becomes 1 over 3 into bracket u raised to power 3 plus 1, 3 plus 1. Now, plus a value of c. Now if you have this, that becomes 1 over 3 into bracket u raised to power 4 over 4 plus c. That gives me u raised to power 4. 3 times 4, that will be 12 plus c. Automatically, that gives me, but the value of u, if you remember, was 3x plus 1. So let's replace it. So if you replace it, you have 3x plus 1 raised to power 4 divided by 12 plus c. So that is a value. But this for integrals. These are for integrals that are function of a function. I'm going to consider another question. Now consider another question of that form. It's easy. Now let's see this. If, for example, you are having a situation where the value is something of this nature, you are giving the integral of 2x minus 1 dx. Now if you take a look at it, you discover that there is a square root out here. For the square root value of this, what you get now is that we say let u be equals to 2x minus 1. So wherever we see this value, and don't forget, I can write this value as 2x minus 1 raised to power half dx. Please don't forget this. It's very important. A square root is the same thing as 1 over 2 as a power. So if I say u is this now, so it shows that du over dx as a function will give me 2. So if I cross multiply this, so therefore what it means now is that dx now, if I cross multiply, is du divided by 2. From here, dx times 2 is 2 dx. Divide both sides by 2, so dx is now equal to du over 2. So dx now is du divided by 2. So please take note of this. So now we have two values. U is 2x minus 1. And dx is du over this. So therefore, let's replace this equation. The equation is 2x minus 1 raised to power half dx now becomes u raised to power half times dx. The value of dx now is not du over 2. So please guys, you now discover that this 2 here is 1 over 2. It's same thing as du divided by 2. So it is 1 over 2. So you take the 1 over 2 out. That 1 over 2 is a constant. So remove the constant from the outer to the back. So what do you have now? 1 over 2 integral of u half du. So now the next thing is for you to integrate u raised to power half on its own. So doing that will take us to the normal thing we do with integrals, and that normal value will be simple enough to tell you now that you have something of this nature. 1 over 2. Now this gives us u half plus 1, half plus 1, plus the value of c. That gives me half plus 1, that's 3 over 2. Half plus 1, 3 over 2. So you have 1 over 2. That becomes u 3 over 2, 3 over 2 plus c. So if I continue with that, my value here will be u 3 over 2, 3 over 2. My 2 will go up to become 2 here. So I'll have 3 times the 2 down. That will be 6. That will be 6 plus c. So 2 up, down here. Well, okay, good. You don't need to bother yourself about that. That's complex computation. So you have 2 times 3 over 2, that will be 3. 2 times 3 over 2, 2 cancel 2, that will be 3. So plus the value of c. So that gives us, what's the value of u again? The value of u is 2x minus 1. So 2x minus 1 will be 2x minus 1 raised to power 3 over 2 plus c divided by 3. So a student just asked me now, somebody is asking me out there, what happened to this square root thing? Square root thing, you can still put the square root. So this is the answer to the question. But you can put the square root if you want the square root or rotational values. You can have the value as root of 2x minus 1 raised to power 3 all over 3. So it depends on you. Whatever you want to do. Please don't forget, the value here, 3 over 2 is same thing as 3 times 1 over 2. So the 1 over 2 itself becomes the square root, then the 3 outside. So you have that. So either you use this or you use this. Because someone is asking me out there, where is the square root? So I just show you that's the square root, if you decide to use the square root. So class, that is that as far as definite integrals with respect to function of a function is concerned. You can have values that are bigger than that, larger values. Good. But
Okay.
now, on indefinite integral, it is possible for you to have an equation, obtaining an equation from dy dx, or a differential equation. But what about a situation where you have to apply, probably you are given an equation, maybe y is 4x squared over 3 plus c. You have something like this. Don't you want to know the value of c? So finding the value of c is the next we want to talk about now. For example, I'm giving, let's take a question like this. Maybe I'm giving y is equals to 8x raised to power 3. And I'm asked to find the value of y when y equals to 1, x equals to 2. Let's try this. It's funny. I'm finding y when y is 1, x is 2. The basic reason why I'm giving the value of y and x to find the original y, which is the function itself. The reason is because I need to find the value constant. Now, let's try to find the value constant. Y is 8, x raised to power 3. It's a statement. Okay, or probably 8 raised to power 3. Let me do this. So the integral, or you have your dy, that's dy over dx to be equals to. So dy over dx is equals to 8x cubed. So the value of y will become integral of 8x raised to power 3 dx. Now, what it means is that the dy dx has been given as 8x raised to power 3. But now, the value of y can only be obtained from the integral or the integration of dy dx. Now, let's integrate dy dx as it is. Now, integrating dy dx is simple. By you saying that if y is equals to x raised to power n, let's take this. So from here, your value of y will become, this is 8x raised to power 3, that will become 8x, 3 plus 1, 3 plus 1. The next value is plus c. That gives me y is equals to 8x raised to the power 4 divided by 4 plus c. I have this. After having this, I'll have y is equals to 4 here, 4. That becomes 2x raised to the power 4 plus c. I have this as the equation. Now we're told that for me to get this function y, I was given this and this as values. So let me substitute these first two values into this. The reason why I have to do that is because I am looking for this value constant c, which is the arbitrary constant. Let's do that now. When y is 1, I'll have x to be 2. So I have 2 raised to the power 4 plus c. So 1 is equals to 2 raised to the power 4 should be 2 times 2 times 3, that's 16. So I'll have 2 into bracket 16 plus c. So 1 is 216. 2 times 16 will give me 32 plus c. So if I move 32 across, I'll have 1 minus 32. See, so therefore, my value of c will give me minus 31. So anywhere I see the value of c now, it is 31. So therefore, this my function equation becomes y is equal to, what's the value of that y again? It is 2x raised to the power 4. 2x raised to the power 4 plus c. That's the value. So from here, the function, which is the original value of this y, becomes y is equals to 2x raised to the power 4. What is the value of c again? C is equals to minus 31. That becomes minus 31. So you can obtain the value of c to get your direct equation when you are given sub-value of y and x to obtain the value of c. Now, we'll consider another question as far as that is concerned. Now, if, for example, you have another value in rotational system, and you are told that dy over dx is equals to, probably you're told that it is equals to 2x raised to the power 3 minus 6x. Maybe I told this. And you are now asked to find the value of y. Find the value of y when x is, maybe probably x is 0 and y is minus 1. So let's try this. Let's take solution for this. dy over dx is equals to 2x3 minus 6x. So therefore, y is the integral of 2x raised to the power 3 minus 6x dx. What it means is that if you integrate this dy dx, you get the value of y. So let's find the value of y now from the integration. So y now will give me, let's integrate. So you have 2x 3 plus 1 divided by 3 plus 1 minus 6x 1 plus 1 1 plus 1 plus the value of c. Now I have this. So from here it's still easy for me to say y is 2x raised to the power 4 divided by 4 minus 6x raised to the power 4 divided by 2 plus the value of c, which is the arbitrary constant. Now let's start the division. 2 here, 2 here. So y will give me x raised to the power 4 over 2 minus 3x raised to the power 4, 3x raised to the power 2, as x raised to the power 2. Here you have 2, that's x raised to the power 2 plus the value of c. Now, I was told from the equation that for me to find the function y, x is 0, y is minus 1. And that was the reason for those values, is to find the value of constant c. So, when y is minus 1, y is minus 1, x is 0. So I have 0 raised to the power 4, 2, minus 3, 0 raised to the power 2 plus c. So minus 1 is equals to, everything here will be 0, everything here will be 0. That is equals to c. So therefore, c is equals to minus 1. So anywhere you see C now is the value of minus 1. So therefore, what becomes my equation? My equation becomes y, which is the function that I'm looking for, becomes y equal to x raised to power 4, which is this, divided by 2 minus 3x squared. What's the next thing? Minus 1. That is my equation. So always remember, when you are to find the value of C, you obtain the function y from two different values of x and y. Sometimes you apply indefinite integrals in the sense that in business analysis, you talk about, for example, you want to look for the total cost per unit of the total cost per unit of a given product. So the thing about it is, for you to get the total cost per unit, so what you need to do is find the value or the equational value of the marginal cost. And the marginal cost has everything to do with time. Is equals to dP over dt. So whatever you get from here, we give you that value of, we'll give you the value of the total cost per unit. So we've come to the end of this class for indefinite integral. We'll meet in other classes. Thank you.